to, there we go. There we go, 2 caught up. Now, we do know what radicals are. They're just a fancy name for things like square roots and cube roots. And we're going to look at how to simplify them. And we're going to focus on only 2 major types. How to simplify square roots. So that's going to be things like the square root of 25, which is easy. The square root of 40, which is going to take a bit of work. And then ultimately, things like 25x squared y cubed. So we're going to find how to rewrite these things in what's called simpler form, right? We're going to simplify it. And once we've kind of mastered that, we're essentially going to do the same kind of thing, but with cube roots. Now, a cube root is a little baby 3 there, so it might be something like cube root 64, that would be a good one. Cube root 80, that might be an interesting one. And then finish with things like the cube root of 125 x cubed y to the 4. And so that's kind of the goal today, is to get these things kind of done. And once we've finished that, I'll spend maybe just a little bit of time talking about the topics for the final. And then when I see you on Wednesday, it's going to be revision for that final. So the final, I keep calling it final, the midterm. So at the end, we'll talk a little bit about what's in the midterm. But when I see you on Wednesday, you are going to hopefully ask me to go over topics or questions that you've found that maybe a bit more practice might help. So that's the kind of the big picture, what we're going to cover today. So let's start with the first kind, and we're going to look at how do you simplify square roots. And they're going to fall into a number of smaller categories. So the first kind of category, I'll call it A, are numbers. So we're going to look at how do you simplify things like the square root of 36, square root of 40. Second type is going to be variables only. So that would be things like the square root of x to the 4 and the square root of x cubed y squared. And last but not least, a combination of them. Once we've kind of covered them, the cube roots are going to have virtually the same kind of format. Well, let's look at the first kind, which are numbers. Now I'm going to write down a very useful table that you're going to use quite a lot, especially in this second kind, these ones here, where what I'm going to do is going to look at a number and its square root. And the numbers we're going to write down are sometimes called perfect squares. So 1 is not that clever because the square root of 1 is 1, but I'm putting that in for completeness. The next number that's useful is 4 because the square root of it is 2. The next one is 9 and it has a square root of 3. You can kind of guess what I'm doing here really is I'm writing down only numbers that have a nice simple perfect square root. Anybody want to have a guess at what my next number in this list is going to be then? I'm going to go all the way up to 100. So what do you think comes after 16? What's the next perfect square? That's a nice square root.
25.
Yeah. And the square root of 25 is 5, right? Okay, let's have another shot. What do you think the next number is going to be after 25 then? So say we're going all the way to the 100. It's not going to be too long.
36.
How are you coming up with these? Are you just seeing them in your head, or do you notice something going on?
For these, my head.
Right. So the next number would be 49, and that has a nice square root. Have you noticed that the answers are going up sequentially? You notice this here? The answers are going up sequentially. So I know what the next answer is going to be. It's 8. And I know that 8 times 8 is 64. So the next perfect number is 64. Do you see I'm kind of working backwards? So the next one would be an answer of 9. And 9 times 9 is 81. So the square root of 81 is 9. So that makes this number 81. And I said I'd go all the way up to 100, so I shall. So when you are being asked to simplify a square root, there are going to be two situations. The simplest one is you're just going to get a number that's a perfect square, and the answer you can get, hopefully by just remembering them. But if you really got stuck, for instance, if it was a big number, like the square root of, I don't know, 225, can you see that the calculator will do those for you as well? So the first kind is very simple. If you get a number inside the square root that's a perfect square, then you can get the answer either by memorizing them or by using the calculator. So now we're going to move on to, that's kind of basically that. So now we're going to move on to ones that don't come out nicely. And this is where the fun really starts. If you want to simplify the square root of 40, what we mean in math is that you're going to try and rewrite this number, still using square roots, but much smaller square roots. And the trick to doing this is to rewrite 40. And it has to be two numbers multiplied together, right? So there's some rules about the two numbers. Two numbers that multiply together, they have to be whole numbers, right? You can't have, 13 and a half times 4 and a half, right? Not allowed. It has to be 5 times 8, 6 times 7, things like that. And the other rule about the two numbers is that it has to be one of these guys. It has to be what is called a perfect square. So I want two numbers that multiply together, and one of them has to be from this list. Can anybody see the number combination that would work then for the square root of 40? One of the numbers is in this list times somebody else, and you get 40.
8 and 5.
Well, 8 and 5 does give you 40. Totally agree with that. Only problem is that neither of those two numbers you mentioned are in this list. So 8 times 5 works, but it's not it has to come from here. So try another combination that gets you 40.
I was looking at the wrong list.
Oh, right. I'm hiding the wrong list. Using only the list that's here now, which by the way is kind of green color. Two numbers that give you 40. I don't want you to say it. I want you to try and get it, because we're going to do a lot of these today. So the sooner we get into our brain getting into the mode, the better. There's definitely one, I can say it. Something times something is 40. And
Is
one
it
of the something.
4
Say
and
again?
10? 4 and 10?
Yes, 4 and 10. 4 times 10. Here's a way you can do it. Forget about 1. As I said, that's just there for completeness. Does 4 times anything get you 40? Yeah, 4 times 10. Found it. Now, what you can then do, because that's like step 1. Take your original number and write it down as two numbers. One of them has to come from this list. Step 2 now. Separate out the square roots into two distinct square roots. So instead of a single square root of 4 times 10, I now have the square root of 4 times the square root of 10. Right, we're almost finished. Step 3. Isn't the square root of 4 a nice number? Can you see the square root of 4 is 2? So what you end up with is 2 square root of 10. And in mathematics, we have simplified this square root. Now, you might think it doesn't look much simpler than it started, but it is simpler because it uses a smaller square root. You know, it's a bit like 4/8 is now going to turn into a half, right? They're both a fraction that isn't a half using smaller numbers. So it counts as a simplification. Here's the next one. The square root is 75. Cover that guy up. That's a bad way of covering it up. I'll use my phone there. Covering it up. Two numbers multiplied together give you 75. One of them has to come from here. And as far as I can see, there's only one combination that's going to do that.
25 and 3.
25 and 3. Was there any shortcut in your brain, or did you just scan through it till you seen one?
I just scanned through it till I saw one.
Yeah, well, that's as good a strategy as any. Now, take this guy, and you get the square root of 25 times the square root of this guy, which is 3. And the square root of 25, I'll take this away now, isn't the square root of 25 a nice number? It's 5. And now you have the answer, 5 square root of 3, and we're finished. Are we beginning to see how this process of simplifying numbers goes? It's all about using this table, right? So you might want to have a copy that, well, you don't kind of need it for the test that's coming, but for the final, you'll need, I would definitely make a copy of this, and for your homework, you would need it as well, just so it's something you look at dead quickly. Okay, how about the square root of 64? And underneath it, I'm going to do the square root of 32. And the reason I'm doing two questions together now is you should always be on the lookout for a nice answer before you start making your life hard and looking for an awkward answer. Do you notice anything about the square root of 64?
It'll be just like 64 times 1.
Well, don't even need to do that. Isn't it just 8?
Yeah, it'll be 8 square root.
Okay. Oh, so you would
square
eventually...
root of 1. I was
Yeah,
telling in the
that...
beginning.
Right. So you would have eventually got 8. That's okay, gentlemen. Yeah. Do you know, some answers are just nice, and that's great. You're never quite sure when that's going to happen, but it's always worth looking. Now, would you agree that the square root of 32 is not going to be a perfect number? And you can tell, as you scan through this list, do you see there isn't a 32?
There is.
There are 32?
16 times 2 is 32.
Oh, you're telling me the next stage. Yeah, you're ahead of the game.
Oh,
So, no, but that's a good thing. You're thinking the way I was going to eventually go. So 32 isn't in the list, but can't you get 16 times 2? So two numbers that multiply together give you 32. One of them is 16, the other is 2. That then splits as the square root of 16 times the square root of 2. And the square root of 16 is a nice number, it's 4. And so the final simplified answer is 4 square root of 2. Okay, there's 3. Bring up, well, can't bring up too much. There you go. I'll give you a minute. Simplify as many of those 3 as you can. Okay, the last few seconds. That's a good boy. Come on now. Up. Come on. Yep. Oh, upsy daisy. Okay, guys. A 30-second break while I introduce Bailey. You've met Bailey before, haven't you? No. This is our dog. He is a big suck up. He was wanting attention there. So, thank you. A little kiss. Another one? Oh, yes, good boy. Yeah. So, well, before I put him down, is he not a cute dog? Come on.
He's really cute.
He is, isn't he? And he knows it, by the way. He is, definitely knows it. And do you know what he's trying to do right now? He's trying to fall asleep. Because he thinks if I'm holding him, he can have a little snooze now. But he weighs an absolute ton. And I'm going to have to put him down. Okay. Whoa. There you go, boy. Okay, let's get this show on the road. I'll take 3 different volunteers, 1 for each question. So if you've got one of the answers, let's share it. Okay, how are you going to split 18? Anybody?
9 and 2.
Okay, that's correct. And that's going to get you the square root of 9 times the square root of 2. So that one ends up being 3 square root of 2. Somebody else now for this one. This is a much messier question, but it does work. 128.
64 and 2.
You got it. And that's the square root of 64 times the square root of 2, 8 square root of 2. And then just so you don't think that every answer in the world is a square root of 2 in the end.
I think I have a different answer for that one.
Oh, well, we'll come back to that one and I'll show you how it becomes this one. So hold that thought and let's finish this one, then we'll return to the 128. So square root of 48. This one doesn't have a 2 in it anywhere. The square root of
16
48.
and 3.
Yeah. And that's going to get you the square root of 16 times the square root of 3. And so you get 4 root 3. Right. Now, we have the square root of 128. And I think it was Jamie Lynn who said she got a different answer. And I believe she did. So can you tell me how you split it? And I'll show you what we can do.
I picked 16 times 8.
Yeah, that's
and then
okay.
The 16 would be square root of 4 and then the 8.
Now, that's the one she's got. And we have the answer 8 square root of 2. I think the analogy I'm going to use for this is, do you know how sometimes you simplify a fraction and you cancel it down and you get 3/6, and then you say, wait a minute, I can do better than 3/6. I can make it a half. This is simpler, but it's not the simplest. This one is the simplest. So if we forget about the 4 for a minute, can you see any combination of 8 that we could maybe break apart? How could 8 be rewritten?
4 and 2.
4 and 2. And that would become 4 square root of 4 square root of 2. 4 times 2 square root of 2. Do you see you still get 8 root 2? It just takes a little bit longer. So the analogy is, think of simplifying fractions. Don't you keep doing it until you can't do it no more. Right, so until you get to the half, right, that kind of thing. Well, when you're simplifying these, any combination that works is good, but always be on the lookout for taking it a bit further. Now, when I get to this point here, would you agree you can't do anything else with the square root of 2? That's as good as that's ever going to be. That way I know I've finished when that happens. But when I looked up here, I would say, I think I can do better. I think I can do the square root of a, 8, work on it a little bit, and then get the answer. So as a strategy, that's not wrong what you did. It's just that you kind of only got 90% of the way, and there was a little extra bump to get to the end. Do we feel comfortable about these numbers, or do you want to do some more square roots with numbers? You feel good? You want more? Okay. So the next list is variables only. So let's start on the page for them. The square root of x squared is x. Think of the square root as meaning half the power. So if I said to you the square root of y squared, the answer is y. Now, technically speaking, there should be an absolute value around these darn things, but sometimes in math we get lazy and we just assume that y is positive without putting an absolute value around it. So that makes everybody's life easier. I agree if you don't need to stick absolutes around things. I wish they just decided to make that rule true in all the other questions we did last week, but that's not the case. So what would happen if I wanted to simplify the square root of x to the 4? Well, you half the power. Think of the square root as halving the power. Well, half of this power would be x squared. What about the square root of b to the power of 10 then? What would the square root of b to the power of 10 simplify down to?
5.
Correct. Half the power. Let's be silly. The square root of c to the power of 100. What would that get? Yeah. In some ways, isn't that less work than trying to do the square of 18s? Right? So right now we've picked the simpler cases, but they do happen, so I'm not avoiding the obvious. Okay, one more. If I was doing the square root of b to the 12, I would get b to the 6.
I have a quick
And-
question.
Yes.
So then if this was with the numbers, it will still be under a square root, but if it's like by itself, it's not under a square root?
Oh, I've just simplified it.
Oh, okay, just showing the simplify of it.
I'm just simplifying it. That's all I'm
Okay.
doing. Now, I thought someone might ask this question, and maybe you were thinking about it, and you're saying, well, that's great if it's even powers. But what do you do the rest of the time? Because you're not always going to get even powers, right? What are you going to do with x cubes and x to the 7s and b to the 9s? How do we do with them? Because actually, once we figure out how to work with them, we're kind of finished. That's pretty much all you can do, right? Even powers inside square roots or odd powers in square roots. So this was even powers. And this is what happens when you have even powers. Now we're going to look at odd powers. So how do you simplify square roots where there's an odd power inside? So let's imagine that I had x cubed. And while I'm at it, I'm going to write some other versions of odd powers. And I'm just pretty much moving up through the food chain, right? an odd power cubed. The odd power is 5, the odd power is 7, and the odd power is 9. And I'm going to show you the answer first. And then we'll try and explain where the answer comes from next. The simplified version of the square root of x cubed is x square root of x. I haven't explained where that came from yet, just trust me, it works. The square root of y to the 5 gets me y squared y. The square root of this guy gets me b cubed square root of b, and the square root of this guy gets me c to the 4 square root of c. Do you notice that there's a pattern here? Right. Have you noticed that there's always a square root left over? And just a normal square root, just with a single variable inside, right? No x cubes inside or x squares, just an x or a y or a c. And have you noticed that there's a kind of pattern on what's outside? Isn't it a power of c? But in this case, it's 4. In this case, it's just x. In this case, it's y squared. Now, I haven't explained why that happens. But if you can see a pattern, you might be able to tell me the answer to that. There's a pattern between this and the answer. And if you use that pattern, you should be able to predict this. Any takers?
Is it x5 square root
Yeah.
x?
So what kind of exponent? X to the,
5?
oh,
Is that right?
not the 5 part, but I like the x part, just the
Okay.
power. So not 5,
7.
I hear 7. And what else would you get apart from just that? Because that bit's right. But what else would you get left over?
Square root x.
Where did your 7 come from? It's the right power rather than 5.
I just followed the pattern, so I took the 14 out and then I left the 1 over. So x14 turns into x7.
You should be here and I should be there. That is perfect. That's exactly what you do. And she actually said it probably in a better way I was going to say it. So I'm going to maybe
Can you
slightly.
explain that one more time? Because
Yeah, oh god, yeah.
missed that.
I'm going to paraphrase what she said unless Dawn wants to say it again.
I took the 14x to the power of 14 square root, which becomes x to the power of 7 with the square root of x remainder.
I'll show you how that works by doing the same thing she said, just writing down the steps, because a lot of people are visual. When you have an odd power, right, x to the 7, x to the 9, anything like that, break it apart like this. So that's when she was saying x to the 14 and x. That's essentially what she was saying. Okay. Now, you can split these into 2 pieces, right? She mentioned something like that. And we already know what this guy is. Remember what this guy is? Remember half the power? So what do you get out of this guy? I see
Connected.
nods.
Okay, yeah.
You see, hey, the bell, the little light bulb, you know, the cartoons, ding, right? I get them sometimes, not as often as I'd like. And you get an x to the 7 and the square root of x. And we have finished this simplification of that. Okay, let's try another one. I'm trying to think of one I haven't done. Okay, b to the 13 then. Split it as b to the 12 plus a b left over. Right, that's 13, right? A b to the 12 and one more makes 13. Then you can split the 2 pieces up. And this guy, half its power is 6. And that gets me our simplified answer. So if we go back here, maybe you can see what's happening here. Can you see that guy is really a 4 and a 1, and the square root of 4 gets you y squared? And this guy here is a b to the 6 times a b, and the square root of the b to the 6 gives you that. You notice that essentially what you get is an even bit and a bit left over, right? And the even bit gives you a perfect non-square root component, and then the little b that's left over. Okay, try one more, although I'm running short of odd powers. T to the 23. God, I don't think anybody would give you that one. But just pretend that we got a question where the power was t to the power of 23. I would split it up as a 22 times another t, right? That's essentially breaking it into two things multiplied. The first piece is a nice guy that works well with the square root. The other bit doesn't. And the square root of any even power, don't you just half the power? And that one would get you 11 square root of t. Do you like that, Jamie Lynn? Are you okay with that? And really all you do in math, a lot of thing in math is that you look for patterns. And then if you see the pattern, you can actually just predict the answer without knowing too much of the math. So let's just do, and I'll have to hide these ones because there's, as I say, there's not a lot of them to do. I'm going to give you 4 questions with just variables in them, and your job is to simplify them, right? Okay, I'll give you a minute and 10 seconds because that's a nice place for my watch to finish. 70 seconds, no pressure. Okay, that's us. Right, this top one, the first one, isn't it a nice even power? So half the power, you just get x to the 7. You can probably do it in your head. Of the 3 that are left, is there any that are nice and easy like that, where you could just basically say the answer and don't need to do anything else?
100.
C to 100.
Yeah, and half its power is 50. Agreed? Have you noticed that the odd powered ones are the ones you have to do a little bit more work to? How would you split 15 up?
X to the 7th and X to the 7th on the outside, and then square root of X.
Yeah, and the little guy in the middle was 14 and 1. I guess if you get good at this, doesn't that middle line sometimes just disappear because you just kind of do that in your head, right? What would the split be, and then what would the answer be for C to the 9?
C to the 8th times C.
And that simplifies down to what?
C to the 4th on the outside, square root of C.
Okay, if it's a single variable, do you feel comfortable about how you simplified them now? We've seen enough of them to be, comfortable at the process. let's try 2 or more variables. So you might get a question where you're asked to simplify x to the 8, y to the 4, right? 2 variables. So what I'm trying to set up here is the process for how you tackle it. So no matter how messy and ugly it is, you follow the process and you'll eventually get the answer. Now, some of you will get really good at this and you probably won't even write half the lines I do. And when that happens, that's fine. But until then, I'm going to write as many lines as I can think of. Step 1. Split your 2 variables into individual square roots. That's step 1. Step 2, take each square root and treat it separate. And use the rules that we've already been using, these rules up here. So here goes. Would you agree the square root of x to the 8 is one of the easy ones to do, right? You don't need to do much work. In this case, you get x to the 4. And would you agree the square root of y to the 4 is also an easy one to do? And what do you get for the square root of y to the power of 4?
Y to the second.
Right. And that should basically, in this case, you're finished. But there will be a step 2 for some questions. So let me show you what this missing step 2 is by giving you a question where you need it. Let's do x to the 7, y cubed. It's not that different from the original. The step 1 is always there. A square root of x to the 7 and a square root of y cubed. Can you see that both of these situations are much more like this question 2, right, and this question 3? Don't we get slightly uglier answers? Now, you can put in the working for this, and I'm going to, but some of you might skip that and just say x cubed square root of x and y square root of y, and that's fine if you can do it. But I'm putting in this line. I'm going to call it x cubed times x, sorry, x to the 6 times x. I'm jumping ahead of myself here. And this guy is going to be called y squared times y. And then I'm going to put in every line I can think of. And this guy is x cubed square root of x. And this other guy is y square root of y. And when I get to there, that's the step 2. That's where you want to end up. Now, some of you, maybe even now, but hopefully sometime in the future, can go from here to here by doing it in your head. So you could hopefully say, yeah, x to the 7 is x cubed root x, and the square root of y cubed is y square root of y. Do you feel comfortable that you might have been able to do that, right? If you can, you do it. If not, that's fine. Now, this fella has one more step. And that is tidying up the answer. Because remember, the whole goal is to make this as simple as possible. And right now I've got some x's and square roots multiplied by some y's and square roots. And I don't really want it to look like that if I can make it look prettier. So what you do is you take those guys together and you take both square roots and put them inside the same square root. So you see how that square root of x and square root of y just becomes the square root of xy. And you see the other two terms come together. And that is the final step in simplifying 2 or more variables inside the square root. So you see it's a little bit more going on there than we did earlier. Try another one. Suppose I want to simplify c to the 4, d to the 7. Then my step 1 is pretty much guaranteed, right? That's my step 1. Okay, see if anybody can do this in their head. If you simplify the square root of c to the power of 4, what do you get?
C squared.
Great. Now this is a little bit trickier, but hopefully you can do it. If you simplify the square root of d to the power of 7, right? D to the power is 7. What do you get? Because you only get 2 bits, don't you? 2 things together.
D cubed plus, or D cubed.
I know what you're
cubed.
trying to say. Square root of d, right?
Square root, yeah.
Are you happy, some of you, from there to there, or do you still need to do this bit to get there? And that's totally okay. I've seen some people who go this way. They just grab a piece of scratch paper and they say, okay, I want to simplify that. And they, they do that line and they do that line. And then they do that. And once they've got that, they write it up here. What's the advantage of that? Well, do you know if you have to do it, don't you end up writing lots and lots of stuff over and over again, repeating yourself, because it takes 4 lines to get to the answer? A bit like what I had to do here. Wouldn't it be easier just doing a bit of the square and coming back, I think. Now, to make it look pretty, in this case, there's not really much. I'm not even sure I've done anything, but that's, you don't really want a times between them, you just stick them together. Okay. Here's 3 variables, which is typically about the most you would expect to see. We're going to simplify the square root of x to the 4, y to the 5, and a z to the 7. What do you think my first step is going to look like, my first piece of working? I don't need the answer, just what would my working look like? What would I do next?
Break down the x to the 4th, y to the 5, and z to the 7th.
You all agree that seems reasonable? It's kind of what you should do, right? That would be my step 1. Now, each one of these square roots, treat them totally separate from the others. Just find out what the simplification of that guy is, then what that middle one is, and then lastly what that guy is. So you're doing really 3 little baby questions in total isolation to the others. So
I think I got to the point where I can just write the answer.
that is a good point to get to, because there is a process, isn't there? And I'm writing down now, as I say, probably more than some of you need, but I think it's good when you look at your notes. So would you agree this guy is going to be x squared? What about y to the 5? How's he going to come out? You want to try it, Jamie Lynn? What does y to the 5 end up being?
Like straight up as the answer or after that?
Just what y to the 5 turns into, what the square root turns into.
Oh, it'll be like the y squared over square root of y.
Yeah. And then a square root is z to the 7. Wouldn't
It'll
that get?
be z cube over z square root.
Great. And then the tidying up is basically x squared y squared z cubed. And then these 2 guys, they go inside their own square root. Math, if nothing else, is logical. once you see how something works, can't you I'm never going to do this, but couldn't you do this with 12 different variables? Nobody in their right mind would ever do that. But can you imagine the square root of A, this, B, that, C, that, D, that? In a way, it wouldn't really matter. Wouldn't it just be big? It wouldn't be hard. You just have 12 variables and you break them all up and you do what you do, whether it was 12 variables or 2 variables, right? It's the same process. So the trick is to realize what the process is and then just adapt it to the circumstance. Do you feel comfortable with the combination of variables now? Can we move on? Do you want to do a practice question or can we just move on this time? I can't really tell. I'm not getting a lot of feedback for this one.
I'd like to do practice more.
Yeah.
Okay.
So let's do another 3 then. Let's do a B10. Oops, I can't do B. What letter? Looks like that. A P. There we go. A P5 and a C cubed. So that's going to split as the square root of B to the power of 10 times the square root of P to the power of 5 times the square root of C cubed. And each one of these gets simplified separately. And if the fella is an even power, which it is here, you just half the power. If it's an odd power, like it is here and here, can't you just say, yeah, well, you could do it like this. I've seen people do this. Do you know some people look at that and say, half of that is 2.5, right? 5 divided by 2 gets me 2.5, and 2.5 becomes that guy. And that's 1.5, and 1.5 gets you that guy. I've seen people say that. So you're taking these two guys and essentially splitting them up in 2 pieces. It's like a whole number piece and a bit left over. So half of 5 is 2.5. Half of 3 is 1.5. Don't know if that analogy helps. And then to finish, all the nice variables go together. And the 2 square roots go together. We're good now? Well, so it's done that one. So the last one in the list, combination of variables and numbers. There's an example of a question that has those things. It's going to have numbers and variables together. So the square root of 20x cubed y to the 5, right? Something like that. First time in your life, probably, for most of you, where you've ever seen this type of question. But we have seen things like it. And maybe we could use the ones that we've done today to kind of figure out how you might tackle this question. Any ideas what we should do as the first step in this process?
Separate each section.
Okay, so square root of 20, a square root of x cubed, and a square root of y to the 5, and that's your step 1. Do that first. If I took out this number here, isn't that very like what we just did 5 minutes ago? if I pretended that 20 wasn't there, right? Wouldn't it be exactly what we did last time? So since we've done plenty of practice at these, won't the x cubed become an x square root of x? What will the square root of y to the 4 become?
Y to
Square
the
root.
second, oh,
Uh-huh.
y to the
Yep.
second, square root y.
Agreed. And I'm doing my little green arrows. That guy became this piece, right? That guy became this piece. What do you think we're going to do about simplifying the square root of 20?
Check our list.
Yeah, I'll bring my list out. Here it is. How are you going to split 20 up then? Remember, one of the numbers must come from here. How are you going to split up 20?
Four and five.
Agreed. And the square root of 4 gets you 2. So it's 2 square root of 5. We still have an x square root of x. And we still have a y squared square root of y. We are darn close. That's step 2. Step 3 is coming up now. We've taken the original and broken it apart and simplified every one of its pieces, but we still have a pretty ugly looking answer. So all I need to do now is figure out how we could kind of put it all back together again so it looks a little bit nicer. So what do you think we do with all these pieces to make that happen? We have a 2, we have an x, and we have a y squared, right? They don't have square roots anymore, so we should probably put them together. And if we did, we get 2x y squared. And what do you think we're going to do with all these square root pieces?
Be 5x y.
Stick them inside the square root
Square
and call them 5xy. Now, for all that hard work, this is the original. This is considered simplified. And simplification in this context just means that the square root part of the answer is smaller than it was when it started. Would you agree the square root of 5xy is much smaller than this? And that's, so don't expect that the simplified answer is really simple. It can be just as ugly looking as the original, but it still counts as a simplified version. One of the reasons why we do things like this is later on, you'll have to add and subtract and multiply and divide these fellas. And it's helpful if you can simplify as well. Because what might happen is that it might start off with 2 really ugly things being multiplied or added, but it could end up being a very nice answer when it's finished. But you'll never be able to do that nice answer unless you know how to simplify things. So simplifying is going to be a process that will help us to multiply, divide, add, and subtract, in this case, square roots. Okay, let's try another one. And I'll let you try that. I won't even give you a time limit. Have a shot at that and see if you can figure out what the answer is. And then I'll just stop when I think enough people have done it. Some of you still writing, so I'll give you a few more moments. Okay, here it goes. This is the original. And the first thing you do without even thinking is split it into its pieces, right? And then each piece we're going to find out what it can be simplified to, and then we'll stick it all together when we're finished. I picked some quite interesting combinations here. Isn't the square root of 25 a nice one? So you get 5. What about the square root of x to the 4? What does that get you?
It'll just be x squared since it's a half of the power.
Correct. And one ugly, right? Y to the 11 is the ugly one in this case, right? And the square root of y to the 11. Have you done enough of them? You just write the answer down now. Square root of y to the 11, then. What does that get us?
Y to the 5th square root y.
And I've just realized I don't need an extra equal, so it's finished. You just got lucky in this one. I thought there was going to be more, but I was wrong. Right, I'm going to give you some nasty, sneaky trick questions. I don't know how you phrase them, but each one has got something weird going on. So here's the first one. This is a trick question. What's the simple version of that? Okay, maybe I should phrase it differently. Can you simplify that? The square root of 3xy, can you do anything to that?
Isn't this already simplified?
Yep, that's what makes this a trick question. It's a bit like, can you imagine getting a homework question with fractions and it said, simplify a half? Wouldn't you be scratching your head and thinking, I can't, that's as good as it's ever going to be? Well, there's an example, right? Not every square root can be simplified, right? Some are already as simple as they're ever going to be. Next one. It's not a trick question, but it is a sneaky question. So this is a sneaky question, not a trick one. I'm not quite sure what the difference is, but there is a difference. Any volunteers for this one? Give you enough time to think about it.
I think it would be like the 2 with just x and then a y over y squared.
Okay. Well, you may be correct. I'm not 100% sure if what
I
you
was
said
just
is what.
thinking in my head.
Yeah.
Oh
Well,
no, I was giving the whole the answer of it.
okay. So I'm split it into bits just to see what that answer might look like. Would you agree that's 2? Can you do anything with the square root of x, which is why this is a sneaky question?
No, because it's already been simplified itself.
But can you do a y cubed? Can you simplify a y cubed? A square root of y cubed? Ah, that's got you thinking.
Maybe they should.
Wouldn't it just be the? Oh shoot! Huh, my head's fuzzy now.
Come on, help her out then. What's she trying to say?
Would it be like y squared square root y?
Well, just
Really?
eventually it would be y square root of y. If you wanted to see what the working might look like, wouldn't it be y squared y? And that would get you to square root of x, y square root of y. You remember when it's odd powers like y cubed, you just get a y square root of y, y to the 5, so on. Right, you put this package together, and that's what makes that one sneaky. You get a 2, check. The x, nothing happens to it, so it ends in here. And the y cubed gets you a y outside and a square root of y inside. So that's the full package. Okay, let's give you 3 examples to try yourself. And hopefully that'll be us for this one. 8 a cubed b to the 7, that's the first one. Here's my second one. And that's my last one. I'll just have it kind of open-ended for a little while. Simplify as many of those 3 as you can. Okay, give you another 30 seconds, maybe to finish off whatever one you're on. Okay, let's get started, see how these go. Every single one of these questions, I'm going to start the same way. You take each piece and separate it as its own square root. So I'm going to have a square root of 8 on its own, square root of a cubed on its own, and the square root of b to the 7. You then work on simplifying each one of these pieces on its own. Some can be very easy, some might be quite messy, but each one gets done separately. Right, the square root of 8 is 4 times 2, so eventually you get 2 square root of 2. Are you happy about the square root of 8 being 2 square root of 2? I've just missed out the line where I called it 4 times 2 and then separated. Now, odd powers, you get a square root of a for a cubed. Odd power, you get b cubed square root of b for 7. Are you happy about those two guys? The square root of a cubed and the square root of b to the 7, right? That's what you do when you have odd powers. And then in this case, the pieces that don't have square roots go first. And anything that has a square root goes inside the single square root. And that would be the end of that question. We cool with that question? Is that the way you were tackling it? If you had time to do it? Second one of the set, this one. Split it as an 81, an x, and a y to the 4. And this one is pretty straightforward, I think. For instance, what is the square root of 81? It's a nice answer, isn't it? Square root of 81.
9.
Agreed. I'll skip the middle one for a minute. Would you agree that the square root of y to the 4, or any even power, is really just half its power? I guess the only puzzle, if it's a puzzle at all, is what do you do about the middle guy, the square root of x? Actually, do you do anything with it?
I would say no.
I agree with you. Isn't it just a little, can't do anything to it, so you just write it down again? Now, rearranging, the things that don't have square roots go first, and the thing that does have the square root, in this case just x, goes last. Yeah, I think in this case, would you agree that's a little bit prettier looking? I don't think this one looks particularly pretty, but it's still simplified. Right, ultimate situation would be when you've got lots of different variables and numbers, in this case, square root of 4, an a squared, a b cubed, and a c to the 5. But one of the cool things is that once you realize that this process is really 4 little jobs, it's not as ugly as it might have seemed. That might overwhelm you, but 4 little jobs that you can tackle shouldn't. Square root of 4 is a nice, it's 2. Square root of a squared is a. Square root of b cubed, well, don't you get 1 and a bit left over? And the square root of c to the 5, you get 2 and 1 left over. Are you comfortable with those 4 pieces? That the square root of b cubed is b square root of b, and the square root of c to the 5 is c squared with the square root of c. Now put all the things that don't have a square root together, and then put everything that does have a square root inside. Okay. Do you feel good about these questions? You feel comfortable about simplifying square roots? I mean, up to things that look as ugly as that. Is there any questions, anything you'd like me to go over? Last chance. Well, we have finished. Can't find my piece of paper, but there we go. We have finished square roots. So we're going to be starting cube roots. But I need a break, and we all need a break. So let's take a 5-minute time out. I know if some of you want to go use the restroom or grab another coffee, you can do that. I'm going to bug some of you. Who am I going to bug? The ones that are left. Dawn, I'm bugging you because you're still here. What's your dog's name? Do you have a dog?
Yeah, her name's Sam.
S-A-M, Sam.
S-A-M, Sam. She's a Mastiff, Dachshund, Pomeranian mix.
Good grief. How did that happen?
By sheer accident.
I would think that combination would be.
The dad was a Dachshund, Pomeranian mix, and the mom was a Mastiff.
Well, I think mixed breeds sometimes have lots of things in their favour, like they tend to be healthier.
Oh yeah, she's not had any problems. She's a real character.
And they can sometimes be quite intelligent. That's not guaranteed, but they can sometimes be quite intelligent.
She's pretty smart. She's food motivated, so she's easy to train with the treats and stuff. So
Well, Bailey, our dog, he's as dumb as two bricks. He's a full West Highland Terrier. We just don't cut his hair like a West Highland Terrier. Well, one is we're lazy, but the second is that he loves digging and sticking his nose in. And if you kept their hair long, you'd be a permanent cleaning job. So we just cut it. Plus, when the summer comes round, it's too warm for them anyway.
Yeah.
So we do that. But he thinks he can climb trees. I mean, he can't climb trees, but he thinks he can climb trees. And he hates squirrels. So when whenever the squirrel is off, he tries to climb the tree. Oh, Alyssa, we're doing pets today. What's your pet's name?
This is Ellie Mae. Oh, Ellie!
Well, no, Ellie's gone.
Come here. Ellie Mae. Come here.
So what kind of dog is Ellie Mae?
She's a Shih Tzu.
I was thinking she might be. My sister's got one. But her eyes, I don't know if that's a breed issue, but her eyes get infected a lot. So I don't know if you've got that problem.
No.
No, you're lucky. Her Shih Tzu is very protective of one person. In my case, it's my sister. So when her husband comes near, she growls at him. So she'll hold him, and he wants to sit down and goes, "Arr." So does yours have that protective instinct?
Ellie doesn't really, well, kind of. Sometimes like wake me up in the morning. My mom will put her on my bed and like kind of like lightly like tap me, and she'll kind of like go after my mom's hands, but she won't like really wake me up. She'll just kind of lay at the foot of my bed and be like, "Why? I'm here."
What about yours, dog, Dawn? Is it a protective dog, or is it just if somebody broke into the house, it would lick them?
He would lick them to death.
Yeah. I think Bailey talks a good game. He backs at everything. But once somebody comes in, he just wants to be their friend. So he's telling us there's someone outside. He's not going to do anything about it. I mean, if they broke in, he would be his friend. But at least he tells us about it. Carla, you've got a cat with a weird name. What's that cat's name again?
It's just Kitty Bitty, or I just call her Kitty most of the time.
Okay. Right.
She's kind of being a pain tonight.
Uh-oh. Attention-seeking pain?
Yeah.
Yeah, well, Bailey was in earlier. He wanted attention, so I had to pick him up. But normally my wife takes care of that business. You know, if I'm teaching, at least she'll snuggle up to him. And as long as he's got a human, he's happy. He's a very human-orientated dog. He does not like being on his own for, you know. And this COVID is kind of, God, when we all start going back to jobs that are outside their house. And I think we're going to have to get a dog psychiatrist for him. I tell you, he is not going to take that well. I mean, even if we go shopping, we come in, it's like we left him for a fortnight. You know, he's freaking out because where have we been? So I hate to think what he'd be like when we do eventually get back to working.
Well, if I study too much or sit in my chair too long and don't take a break and give her attention, she starts acting out. She's an old lady, so, you know, they just kind of set in her ways.
Yeah, I hear you. A lot of pets bring a lot of joy to people's lives. I think if someone is good to a pet, and I can see they're good to their pets, it tends to be a reflection on how nice that person is. I think somebody who's bad or evil to an animal or a dog or something, they're not going to be particularly nice to humans either. You know, I think you're seeing something in them when they're like that. Yeah. Can't understand why people are evil and bad to dogs. They're just some evil people, I guess, in this world. Yeah. Well, I think we should finish with the joke, and then we'll start our next topic, which is going to be cube roots. And you could kind of guess how it's going to work. You've kind of seen the sequence I'm going to do, and we're just going to do it with cube roots, and they're pretty similar, but a little bit harder probably. So I'm trying to think of a joke here.
I might have a joke that
go on for it.
that you might understand. It's a Scottish joke, so I'm not sure if I might do it right.
No, go for it.
Okay, it says, "What did the Scottish guy do with a trumpet buried in his garden?"
I don't know. What did he do?
He rooted it out.
Right.
He rooted
No,
it
you
out.
said it well.
Yeah.
Rooted it. It's how Scottish people speak. It's, yeah. He rooted it out means he dug it up. That's a phrase. Rooted something out. Well, not a joke, but it's given me something to tell you. There are certain things that we say in Scotland, and how am I going to describe what I speak? I have a telephone voice. I think that's how I'll describe it. Do you know how if you're at a job and you pick up the telephone, you do your telephone voice? I mean, if it's your sister, you do your normal voice, but when it's a stranger, you do that polite, easy to understand accent. And because of my job, I have a telephone voice. This is not how I speak when my sister is around or when I get back to Scotland. In fact, when eventually I do get back to Scotland, when I come back to America, the secretaries tell me it takes them a fortnight to understand me again because I went back to my roots. But here's a few ways in which we say things that are different. We have a hard E sound. So you would say bread and we would say breed. And you would say head and we would say heed. Right? So you could say, you know, somebody wanted some breed and he got hot in the heat. Hot means hit. So we would say hot instead of hit. We roll the R. I try not to roll the R's a lot, but I think the Spanish language rolls the R's a little as well. There's a nonsense poem that we have in Scotland, and you go, and it gets you to do the R sound, and it goes something like this: "Round a rugged rock, a rugged rascal ran." Right. So can you hear the R sound in there? Now I try and temper the R sound, but it's there. When I get back home, I don't temper anything. I just get back into when I talk to my sister every week. So Sean, are you ready to get embarrassed?
Sure.
Okay. Round the rugged rock, the rugged rascal ran. Go for
Yeah, I'm not even gonna try that.
it. Okay, I'll take an open volunteer. Somebody go for round the rugged rock, the rugged rascal ran. Not one of you wants to.
Good rascal friend.
Come on. Who says that? Thought someone was trying it there.
I can
Well, I
kind
was
of.
trying it, but
It didn't come out. Okay for it. Right, go for it, Carla.
say the sentence one more time.
Round the rugged rock, the rugged rascal ran.
Round the rugged rock, the rugged rascal ran.
That's pretty good. There was a lot of R sounds in there. Rachel, can you do any R sounds? Have anybody here got Hispanic background? Because they must be able to do the
Wait, can you
R's.
repeat the phrase again?
Okay, you going for it. Round the rugged rock, the rugged rascal ran.
So it's like around the rugged. so it's like around the rugged. God damn it, I'm too tired.
Oh, you did good. Well done. Well, so if you ever get to Scotland, you'll hear a lot of those sounds. The hard D is very common. So people are deed in Scotland, are not dead. Right? It sounds like D-E-E-D, but that's how we pronounce it. So there's a little language lesson on how to speak according to the Scottish vernacular. And there we go. So let's look at cube roots. So once I finish this, I'll be spending a little bit of time talking about the general overall, what the midterm's going to look like. I'll be going into Canvas in particular to do that. And then we'll be finished, but we've got a lot of stuff to do. Now, can you remember how I started? I'm seeing if I've still got it handy. Yeah. Remember how we started with square numbers and we had a table? These are called perfect squares. We're going to do the same thing again. And we're going to do what's called the cube root. So whenever you see that symbol with a 3 there, right, some number or expression inside it, we say this out loud as the cube root of, and then you say whatever the dots are. So there are some numbers that have nice cube roots. That one is just there for completeness, so it's never used. The next perfect cube is that. Now, a cube root is a number times itself again that gives you 8. So the cube root of 8 is 2, because 2 times 2 times 2 again is 8. Okay. The next cube root is 27. That's a perfect cube. And the cube root of 27 is 3. Now, the table that you typically use for cube roots is much smaller than this one. What's the next perfect cube? What's the next number that's going to be here? There is a pattern. See if you can follow it. Last chance.
64.
Well done. And the cube root is 64. Is 4. If you want to work backwards, 4 times 4 times 4 is 64. Cube root of 64 is 4. So won't the next one be 5? And what's the perfect match for 5? Well, 5 times 5 times 5 is 125. So the cube root 125 gets you 5. So there we go. And that is typically as far as the normal kind of table goes. Now, if you get a really large number and you would like to check it out, there are a couple of ways you can do it on the calculator. One, depending on the kind of calculator you've got, you can find the cube root button, but it's kind of well hidden in TI-84. So I'm going to show you another way of getting it. Suppose you take 125 to the power of 1/3. So a 1/3 power is the same as a cube root, and a 1/2 power is the same as a square root. So if I put in a number like 1,000 and I wanted its cube root, I'd go to the power of brackets 1/3, and there's our 10. And if I wanted the cube root of, I don't know, 64. If I wanted the square root of 64, I would just raise it to a 1/2 power. So if the numbers get really big, you might want to try the calculator in case it's a nice perfect cube. So we are going to be doing with cube roots pretty much the same combinations as we did with the others. Let's look at numbers first. And they're going to break into 2 groups. There's going to be the cube roots that are really nice and have a nice perfect answer. And there are not that many of them, and they're mostly in this table. So if someone said to you, what's the cube root of 125? The answer is, it's 5. Of course. You might be able to tell me what that one is, because it is a perfect number as well. It's a perfect cube. What's the cube root of 1,000?
And
10. Right. Quite hard to find ones. Okay, I'll just pick that one. Would you agree the cube root of 27 is 3? So you're probably not going to get many perfect cubes, right? I mean, there's 5 here, and I wouldn't even count that one as one. So you could almost memorize those ones. So you're more likely to get questions where you've got a cube root that isn't in this table. So you might get a cube root, oh, I don't know, let's say 54. And your job is to simplify it, just like we did with the square root of 54, right? And so if you want to simplify it, you do a very similar job. You find 2 numbers that multiply together that give you 54, but one of them has to come from here. Now you can see when there's a limited choice, it's maybe a bit easier to find the one that works. 2 numbers multiplied together give me 54, and one of them must be from this list. So what are my 2
It'll
numbers going to be?
be 27 and 2.
Would you agree? 27 times 2. Now, the overlap between how I'm going to deal with cube roots and square roots is very strong. It's going to look almost identical kind of working. Can you imagine what my next step would look like? Well, you split it, and I'm doing it the long way again. You split it into 2. And isn't the cube root of 27 a nice answer? It's 3, and you can't do much else. And there's your finished result. The simplified version of the cube root of 54 is 3 times the cube root of 2. Mathematically, isn't that very similar to what we did with the square root of 40 and square root of 72 and all those other examples that we did, right? So the methods pretty much the same. The application is a little bit different, and the only difference is that cube numbers, right? Perfect cube numbers are not really the same as perfect square numbers, right? There's a few overlap, but mostly they're different. Right, let's try another one. Okay, I'd like to simplify the cube root of 24. So I need to split it as two numbers multiplied together. And one of them needs to come from this list. So how am I going to split 24?
8 and 3.
And then the cube root of 8, followed by the cube root of 3. And the cube root of 8 is a nice answer. It's 2. And the other guy just gets left alone. And that's basically this final result. We good? How about the cube root? Oh, let's try and make life hard for you, everybody, including me. There, that's a pretty big one. Probably at the top end of what you'd be expected to do. Cube, and I can see someone already doing what I would suggest you do in this question. And that is, shouldn't you try this number and see which one of these it matches with? And you can do that by simply just dividing. So what's the cube root of 320 going to split up as?
It'll be 64 times 5.
So imagine what I might do. Okay, I'd say 320's got to go with something, right? I'll try it with 8. 320 divided by 8. Well, that one works, but can I do better? Well, I can. I can go 320 divided by, say, 64. That one works. Right, we break it into its pieces. Cube root is 64. Cube root of 5. The cube root of 64 is 4. And the other piece is finished. So simplifying numbers is basically finding two numbers that multiply together that give you the original, but one of these numbers has to be the biggest number that you can find in this table. Okay, let's give you 2 guys to try out. Hopefully that's enough practice and then we'll move on. So I'd like you to find the cube root of 40 and the cube root 250. Okay. I've it open-ended. I'll give you a little warning closer to the end. Yeah, last few seconds. Okay, here goes. 40. Give me the two that work with 40.
8 and
One of
5.
them has to be from here.
8 and 5.
8 and 5. And that becomes square root of 8 times cube root of 8, cube root of 5, and you get 2 cube root of 5. Right, 250. Actually, it's easier than it might look. 250. What combination works for 250?
125 and 2.
And the cube root of 125 is 5 with a cube root of 2. Now, when you're dealing with cube roots, would you agree there's typically only a few numbers that you're going to be using? I mean, there are lots of numbers after that, but they're so big that it's unrealistic to expect you to see them. Maybe 1,000's a special case, but that's about the only one. Are we good with numbers? Can we move on to single variables? Good. Okay. Now, very similar to what happened with the square roots. I'm going to look at single variables. These guys are nice guys. What do I mean by that? They give you an answer that's perfect. There isn't any cube roots. Can you remember that square roots were half the power? Remember we said, look, square roots are like halving the power. Does it seem reasonable that cube roots 1/3 the power? In other words, you divide the power by 3. So this guy, if you divide them by 3, perfect match, right? There's nothing left over. In this case, if you divide it by 3, perfect match. In this case, if you divide it by 3, perfect match. And what's the top one going to get you?
X.
Just X. Are you comfortable then about cube roots of powers that are in the 3 times table, right? So the cube root of d to the 300 would be d to the 100, right? They're not the hard ones. The hard ones are single powers that are not in the 3 times table. Like that guy. And there are 2 distinctly different ways to tackle this question. I'm going to show you both methods, and then we'll you tell me which one you like best, and I'll try and stick to that method for the rest of the questions. I don't like jumping between 2 methods too much, because what tends to happen with students is if I show you 2 methods, you don't remember either of them. What you remember is a Frankenstein method, which uses a bit of the first method and a bit of the second method, and it never works, right? So here are the 2 different ways to tackle the cube root of powers that are not in the 3 times table, right? So that would be things like c to the 7, c to the 11, right? C to the 22, right? Things that don't match perfectly in the 3 times table. In this method, you split it into 2 pieces. One of the pieces is in the 3 times table, in this case 6, and then whatever's left over, in this case. Technically, there's a 1 there, but we never write it. Are you comfortable that that guy can be written like this? And then you split it into 2 separate pieces. Can you see where we're going next? So what's this piece here, the front piece, going to simplify down to?
C2.
Agreed. And then isn't this just the bit that's left over? Right, that's method one. And a lot of people like that method, and you might be one of them. That's cool. And here's the next method. I'm going to try and divide 7 by 3, right? Now, it's not going to come out exactly, would you agree? Isn't it going to come out as 2 1/3? And that's going to be the c squared, and the third is going to be the cube root of c. So the whole number is the bit that goes there, and the fractional bit is how many cube roots you've got. Now you can see these are quite different looking techniques, right? Do you have a preference?
I like the top.
You like the top? Would that be a general preference? Right. So that's a backup plan. If you don't like the top, you can do your homework, you can do tests, whatever, using this method. It's totally correct mathematically, so it's not like you're doing something wrong. But we'll show you the top method. So let's do cube root of b, b to the 10. Okay. Now you have to split b to the 10 as 2 powers, right? A b to the something and another b. And the first one has to be in the 3 times table. And what's the biggest number you can get in the 3 times table without going over 10?
8.
3 times table? Not 8, 3, 6. Next one?
9.
9. Right. And one left over. And that becomes the cube root of b to the 9 times the cube root of b. And what does that get you? B cubed, cube root of b. Now this one's going to be, this one might tax you a little bit, but it's still the same process. You're going through the 3 times table, but you can't get beyond 14, right? So in your head, just go through the times table until you finish, right? So what's that? 3, then 6, then 9, then and so on. What's the most that you can do for a 14? Biggest number in the 3 times table without going over. What can you get to?
12.
12. How much is left over? Because that isn't that. If I left this as x, this would just come to x to the 13. Do you see that? Do you agree it's 12 and 2 left over? You didn't get that in square roots, didn't you? In square roots, you just had a perfect answer or 1x was left over. But you see in cube roots, can't you have 1 piece left over or 2 pieces left over? Right, that can happen. Now, actually, it's not as bad as it seems. You split it into, I forgot my cube roots. You split it into its 2 pieces. And would you agree the cube root of x to the 12 is the nice piece, right? That's the piece that works well. And that goes what? X to the 4. And you might think, well, what do I do with the bit that's left over? Nothing. That's the answer. It's just left over. It's an ugly orphan piece that you have to just live with. Okay, let's do simplify the cube root of y to the 17. How's that going to split? What's the biggest number in the 3 times table that you can use without going over 17?
15.
Great.
Oh my God, are they gonna?
And how much is left over in this case again?
2.
2. And when you do the split, you get that guy who's going to come out nice, and you get this little ugly orphan bit that you just left with. And this guy gets you 5, because perfect match. And this guy just gets you the orphan bit that's left over. Do you want me to do some more of these guys?
Oh, why did you pick Y15 to the perfect?
I'm going to go through 3 times table because I know anything that's in the 3 times table is going to work well with the cube root, because 3 will go into 15 5 times. So I'm trying to find the bit that's going to get taken care of with the cube root and come out as a nice power. So it has to be things like y cubed, y to the 6, y to the 9, y to the 12, y to the 15, right? It has to be in the 3 times table. So that's why I picked that one. And then the bit that's left over is just the bit that's left over. And so what we've done is we've taken this one and simplified it by pulling out the most we could and leaving whatever is the orphan bit that's left over.
Okay,
So,
I thought we could only use numbers like from the
from up here,
yeah.
yeah, this is what you use when it's numbers that you're doing it to. So if it's a cube root of 82 or something, you use these. But if it's powers, it's a kind of different rule. If it's powers, it's this 3 times table kind of trick that we use instead. So they're quite different, how you simplify numbers and how you simplify powers, right? They're quite different techniques. How about this fella then? Cube root of b to the 13. Right, try that one yourself. See if you can do it before I get to it. Okay, we're going to have to make this the last question for today, and that's fine. We're ahead of the schedule, so I'm not too worried. Okay, how are you going to split 13?
B12 and B.
Yeah, B12 and 1 left over. And that's going to split as a cube root of b to the 12 with a cube root of b. But the cube root of b to the power of 12, doesn't that come out nice? Right. Anything that's a multiple of 3 inside a cube root can simplify really well. Remember, you're just taking a third of the power, and a third of 12 gets you 4, which is kind of why we did what we did. Now, I have an atrocious memory, so you lot are going to remind me, not this coming Monday, because that's going to be our midterm, but this coming Wednesday, a week on Wednesday, that we only got this far, so that we can continue with 2 variables and then mixture of numbering variables, right? So we have that to do, but time beat us, and I want to show you a little bit about what's happening on Wednesday and give you a kind of rundown of your midterm. It's a biggie. I can't emphasize this enough. So one of the things I want to kind of do while I'm getting this up, why don't you all say hi, so if I forget, you've got that done, is I want you to make sure that that you get your homework done. because I have noticed that some of you are getting a little bit behind. And your homework is important for not just your grade, but that's really how you practice questions for the test in the midterm. I think we're about ready. Yeah, where is the guy I'm looking for? Here it is. Okay. I'll just make it a little bit bigger. Go into student view. Good. Can I do it any bigger? That's the question. Okay. Does anybody know what percentage of your grade is going to be from your midterm? It's in the syllabus, but can anybody remember how much it is?
I think you said like 30%.
Yeah. Now, you know that can make or break you. You know that if you do really badly, it's going to harm your chances of passing. And I don't want, nobody wants that to be the case. So you're going to be trying to be as prepared as you can. So when I see you on Wednesday, you're going to have a nice list of things that we're a bit rusty about, or things that you can add a gloss over, and you'd like maybe, you know, me to do something. And sometimes it's just that, you know, we had some people with a little light bulb today, didn't we? You know, yeah, never get it, right? So hopefully we can get a couple more of those on Wednesday. Now, what you should be looking at right now is the topics that are going to be in your midterm. So you won't get anything on getting started with WebAssign, but you will get two main sections on what your thing's going to be about. The first one is going to be about linear equations and solving linear equations. So you're going to get questions about graphing on square paper. So by the way, get some square paper. It'll just make your life easier. Bookstore. I think you can get square paper almost anywhere, can't you, if you go looking for it? If you've got a printer, you know, you can go online and just print out some square paper. It's maybe not the most efficient way, but you'll need it because you're going to graph things and then you're going to solve equations. So you know the kind of things like the addition method and the substitution method. And then you're also going to get questions where you do applications. You know, the ones like 4 hamburgers and 3 fries cost $8, and 2 hamburgers and 5 fries cost $12. You know, how much does it cost to buy a hamburger and how much does it cost to buy fries? Those kind of questions. And that's basically what you did during week 1 and 2. And then the second major chunk of work is fractions. So how to simplify fractions, multiply and divide them, add and subtract, didn't really do too much of that. Complex fractions, remember those multiplied by special versions of 1. And solving some rational equations, right? So solving fraction questions. 9 and 10 really go quite strong together. And really just a very basic start to the definition of square roots and cube roots. Things that it's a really good idea to get brushed up on is you are going to be doing an awful lot of factoring in that 6 to 10 section, right? You know, the magic cross method for the difficult ones, but common factors and x squared minus 2x plus 1, you know, those kind of situations. Because in a lot of these questions, isn't that the main process, right? You factor things and tidy them up afterwards. So it's going to last your entire Monday. It'll be a 3-hour stint. And what's going to happen is that you're going to be given a PDF. Right? It's just I'll see if I can go out a bit. Okay, so what's going to happen is that you're going to come and there's going to be a heading that will say midterm exam. And in that heading, there will be 2 links. One of those links Let me show you in another class that's done a test what those would look like to you. Okay. One of them is just going to be a link, and you click on it and it opens up the PDF, and the questions are there in front of you, and you will write your answers down. And then your job is to take those guys and convert them there. This is what my test 2 looks like. So yours will look something similar to that. So see how it says a PDF of test 2 is here? You will have a PDF of your midterm. When you click on it, it'll look this is a different class, but you know, this is what the test will look like. So it'll have solve these equations, simplify these fractions, and so on. And you do your working on paper. And then you're going to say to yourself, well, how do I get my answers from my piece of paper to you? And that's something that you're going to practice on. And essentially, you're going to use a guy, unless you've got other means, called Adobe Scan. So here is a video how to use it. I'll put that up. And that'll be up by Wednesday. Right, so when we start, I'll show you that. But this will be the same video. You click on it, and it tells you how to use Adobe Scan. Essentially, what you do is you take a picture on your phone of your working. Right, next page, picture, next page, picture. And then this software turns it into a PDF for you. Right, and you got that. And then you go, once it's turned into a PDF, you'll have a guy that looks like this, and it'll say upload your working for the midterm year. And you click on this, and well, I better go into student view because I get a different view from you. So you've done your test. It's in paper. You've taken pictures using this. It's free, by the way, the software. And now you're going to upload your working. So you click on this. Oh, darn it, I can't show you. Sorry. I'll make sure that ours is. The deadline has already passed, so it won't work. But what would happen is, if I had one up and running, is you click on it and it just says upload file. You click on it, and I'll show you on Wednesday. You've got your thing saved on your desktop or your computer. You click on it and you upload, and you're done. So essentially, you take pictures, get turned into a PDF, you put them on your desktop, you go to this party canvas, and you upload it, and that's how I get to see your working. And when you're doing your midterm, show working, show working, show working, because you get partial credit. If you do it all in your head and you write down 6 and the right answer was 9, I can't give you anything because I don't know what you did to get your 9. But if you do as much working as you can do, if it's half right, you get half the points. My experience has convinced me that that one simple rule of always showing as much working as you can will get you a lot of points. It never loses you points, right? But it could gain you some points. Any questions before we finish today?
Do we get to know how many questions there will be on the test?
You will as soon as I've written the darn thing, but I haven't even thought about writing it yet. It will be in 2 parts. There will be a first part, which is multiple choice, which basically you get a question and there's 4 or 5 answers and you pick the right answer, A, B, C, D, or E. And for those questions, I don't need to see working, and probably you shouldn't do it because it'll slow you down. Right. And there'll be typically there's 10 of those. That's what I normally do. Those are the kind of questions that are pretty straightforward. You know, like here is y equals 2x plus 4. And I show you 4 pictures and I say, which one of these pictures is y equals 2x plus 4? And you say it's picture C, right? That's it, right? So you get 10 questions, nice short, hopefully short questions. And then the second part, which is where most of your points are going to be, they'll probably be in the range of 10 plus questions. So if you look at the list that I gave you earlier, you know, all the homeworks, pretty much you're guaranteed 1 question from every one of those sections. And occasionally some sections will have 2, but not many. So that's why I'm saying kind of 10 plus.
I'm gonna need to speak to you when all the other students leave.
Sure, we can do that.
Yeah, it'll confuse them, so I'll just wait
Okay,
until
I got
everybody's
you.
done. But
Not a problem. Any other questions? Carla's going to be here in the end, so she'll wait until she needs to. Any other questions?
I don't know if you already said this, but
Huh?
are we allowed to use notes on the midterm?
You are allowed to use notes, so write really good ones that make sense to you. They don't need to make sense to any other human being, but there are lots of ways of doing that. I've seen people do cards where on the front of the card they write the question, and then on the back they kind of do a standard answer to what that question would look like. You know, step 1 do this, step 2 do this, step 3 do this. That's quite a useful thing to do. Whatever works for you. Some people do notes differently than that, and that's totally okay. But yeah, what won't be visible is all of WebAssign will disappear for the midterm. So you won't be able to go to WebAssign and look at questions that you've seen on the midterm, because my midterm questions will be pretty much, for the most part anyway, just like WebAssign questions. I'll probably go in and look at some WebAssign questions, just change the numbers. So there won't be anything, for the most part, you're going to say, I've never seen that question before. At least I hope you'll never have that.
I think you said this also, but on WebAssign, are you gonna have like a practice type of thing, or just like other questions that we could go back to review?
I don't have that in WebAssign, sorry. No, I don't is the short answer. I'll see if I can look up something like a previous exam. I should be
What
able.
about like old homework assignments? Because I know the first set is gone already.
Well, they're gone, but I can bring them back to look at. But I will take them off on the day of the midterm. So if you want to, that's something I can do pretty easily. Right. I'll see if I can find an old test somewhere and put that online. But the problem with that is I'd have to make a solution to it. And I wish I had time. I really do. But I get 5 classes and stuff. And so it's hard. But I'll take a note of that to make visible. Is the early homework totally invisible? You can't see it at all? Is that what you're saying? Yeah, I can fix that when we leave then. So after I've spoken to Carla, give me half an hour if you want to find out what it looks like. And you should be able to go back and see all the previous homework
Okay, sounds good. Thank you.
to look at. And I don't know if you can go in and give me another example. You might or might not be able to do that. Okay, any more questions for today?
Oh, and I was wondering if you have class recordings on our classroom.
Yes, all of them are in Canvas. So if you go to your Canvas site, it's called something like Zoom class lessons and videos. And if you click in that, it's got all of the, including this one eventually, although this one probably won't be up until tomorrow.
I have a question.
Mm-hmm.
How much time will we have to complete the final or the midterm?
3 hours plus some time after that to do the Adobe scan time. So if you're a little bit concerned about the Adobe scan, it's not the only way to do it. If you've got a printer that can scan and turn things into PDF, you can do it that way as well. And I've been told by other students that they've got English classes where they did it with a different piece of software. I don't care how it turns into a PDF, it just needs to be turned into a PDF so it can be sent to me so I can see it, essentially.